Hello everyone and welcome back to my YouTube channel. My name is Ernest Shah. Today the subject is Java and the topic is two paradigms. Java programming, a dive into two paradigms. Welcome to the Welcome to this exploration of the two dominant paradigms in Java programming: object-oriented programming and functional programming. We'll dive into their core concepts, principles, and how they coexist in modern Java development. Get ready to discover how these contrasting approaches can enhance your coding strategies. Object-oriented programming, the foundation. Classes. Classes are blueprints for objects. They define attributes, data, and methods behavior, common to all objects of the class. Think of a car class that specifies its make, model, and functions like start and accelerate. Objects. Objects are instances of a class. Each object has its unique state, represented by the values of its attributes. In our car example, you have a Honda Civic object or a Toyota Camry object, each with its own specific data. Oops, OOP concepts: inheritance and polymorphism. Inheritance. Inheritance lets you create new classes, subclasses that inherit properties and methods from existing classes, also superclasses. This promotes code reuse and extends functionality. For example, a sports car subclass could inherit from the car class, gaining its basic attributes and methods. Polymorphism. Polymorphism means many forms. In OOP, it allows objects of different classes to be treated as if they were the same type. Thanks to shared methods, for example, a vehicle class could have a move method and both car and motorcycle objects could call this method to move in these specific ways. Functional programming, a different perspective. Immutability. Data is treated as Data is treated as immutable, meaning its value cannot be changed after creation. This prevents unintended side effects and makes code easier to reason about. In FP, you work with new copies of data rather than altering existing ones. Pure functions. Functions in FP should always produce the same output for the same input without any side effects. They don't alter global state or rely on external factors. This makes functions predictable and testable. Higher order functions. Functions can be treated as values and passed as arguments to other functions or returned as results. This allows for powerful abstractions and flexible code. Contrasting paradigms: OOP versus FP. Emphasizes data encapsulation, object interaction, and inheritance. It's great for modeling real world scenarios and building complex applications with reusable components. This is OOP. Now, FP focuses on immutable data, pure functions, and transformations, ideal for non-currency data processing and creating conceived predictable code. Object-oriented programming. OOP is a dominant paradigm in Java. It revolves around the concept of objects that encapsulate data, fields, and behavior. It promotes code reuse, modularity, and scalability. Key concepts in OOP: class and object. Class defines the blueprint, and objects are instances of these classes. Encapsulation, restricting access to certain components of an object. Inheritance, allowing one class to inherit properties and behavior from another. Polymorphism, allowing methods to perform differently based on the context. Abstraction, hiding complex implementation details and exposing only the necessary features. Functional programming. Introduced in Java 8, FP is a paradigm that treats computation as the evolution of mathematical functions and avoids changing state and mutable data. It emphasizes declarative code. Key concepts in FP: first class functions. Functions are treated as first class citizens, meaning they can be passed as arguments, returned from methods, and assigned to variables. Immutability, avoiding shared mutable state. Pure functions. Functions that return the same result for the same output and have no side effects. Higher order functions. Functions that can take other functions as arguments or return them as results. Stream API enables processing collections of data in a functional style. Comparison of OOP and FP in Java. Aspect: object-oriented functional programming. If we consider focus, objects, data plus behavior. In FP, it's functions and data transformations. State management in object-oriented programming. Its object-oriented programming is a mutable state, whereas functional programming is immutable preferred. Code style in OOPS is imperative, whereas in functional programming is declarative. Introduced in Java from the start, whereas functional programming was introduced in Java 8 and later. hybrid approach, blending OOP and FP, combining strengths. Java allows you to leverage the advantages of both paradigms within a single project. For example, use OOP for defining complex object modules and FP for concise data manipulation, enhanced code. This hybrid approach can lead to more readable, maintainable, and efficient code. It offers flexibility to choose the best tool for each task. Java 8 features for FP streams. Streams provide a way to process collection of data in a functional manner. You can chain operations like filtering, mapping, and reducing, simplifying data manipulation. Lambdas. Lambda expressions allow you to create anonymous functions which are often used with streams and other function features. This makes code more compact and expressive. Method references. Method references provide a concise syntax for referring to methods. They make it easier to use existing methods in a functional context, furthering simplifying code. Weighing the pros and cons. OOP. Encapsulation, code reuse, well-established model. FP. Concurrency, readability, immutability. Hybrid. Flexibility, both a bedward-tailored solution. Choosing the right paradigm, a guide. Project complexity. For highly complex projects with object-centric models, OOP might be suitable. Data manipulation. When dealing with large data sets and transformations, FP offers advantages in performance and clarity. Team expertise. Consider the team's familiarity with each paradigm and their ability to contribute effectively. Project requirements. Prioritize features that align with the strength of each paradigm. FP may be advantageous for non-currency, while OP excels in object modeling. Conclusion. Embrace the power of choice. Understanding and applying both OOPS and FP principles opens up a world of possibilities in Java development. By embracing both paradigms, you can build robust, efficient, and maintainable applications that meet diverse needs. Remember, the best choice is the one that aligns with your project specific requirements and your team's skill set. Happy coding!